Hello and welcome to exercise 2 on page 61. In this problem, we are going to be finding y prime if e to the xy plus y squared equals 2x. Okay, and in this example, I'm going to use the shorter of the two methods for finding a derivative using implicit differentiation. Again, you're welcome to use the longer way if that works better for you. Okay, so the shorter way of doing this is to start by just taking the derivative of both sides without bothering to relabel the y's with f of x's. Okay. Okay, what that means again is that we have to remember that every time we see the variable y, it's really holding the place for a function or maybe several different functions, and we have to treat the y accordingly as if it were a function. Okay, so first thing we come to is the e to the xy. We need to take the derivative of that. Notice that that's a chain rule where the u is just the xy. So we'd ask ourselves, how do we take the derivative of e to the u? Well, we're just going to get e to the u right back again. And then the second part of the chain rule says we need to multiply by the derivative of u. So e to the xy times the derivative of xy. Okay, and then we come to y squared. Okay, and here's where we have to be careful. That y that we see, remember, is holding the place of a function. So it's like taking the derivative of f of x squared. We need to think of that y as being a u. So when we take its derivative, we're going to get 2u. But then there's that second step of the chain rule. We need to multiply by the derivative of the u, which puts a y prime at the end of that. Okay, and then over on the right-hand side, derivative of 2 times x, that's just 2. Okay, we're treating x as we ordinarily would. Okay, and continuing to the next step here then, we've got an e to the xy that we're done with. And now we need to take the derivative of x times y. Notice that that's a product, x times y. And so we need to use the product rule to take that derivative. So let's see, we're going to get the first times the derivative of the second, and the derivative of y is just y prime. Okay, plus the second times the derivative of the first, and the derivative of x is just 1. Okay, plus 2y prime equals 2. Okay, so we've taken all of our derivatives. The next step is to solve for y prime. That's what they wanted us to find in the problem. Okay, before we can do that, though, we need to do a little algebra here. We've got this set of parentheses. And so to kind of free up all the terms, let's go ahead and distribute this e to the xy through. We're going to multiply it through by both of those two terms. And let's see, the first thing we'll get is e to the xy times xy prime. Okay, and then multiplying it by the second term, we're going to get e to the xy times 1, which is just e to the xy times y. Okay, plus 2y prime equals 2. Okay, and you remember what we did when we got to a situation like this before. Okay, we've got a y prime sitting in two different places in our equation, here and here. And so what we'd like to do is make use of the factoring method. We can do that by just getting all the y primes by themselves on one side. So we're going to subtract this one term that doesn't have a y prime in it that's on the left-hand side. We'll subtract it over to the right-hand side. Okay, and if we do that, we're going to get e to the xy prime plus 2y prime equals 2 minus e to the xy times y. I'm going to rewrite that as y times e to the xy. Okay, maybe a little bit more natural to put the y in front. Okay, and now on the left-hand side, we can factor the y prime out of there. Okay, so we'll get y prime times e to the xy times x. Actually, I'm going to put the x in front. Doesn't really matter what order you do it in, but I'm just going to make the choice to write the x first. Okay, and can you see what the last step here is? Okay, we just need to divide both sides by x e to the xy plus 2y. Okay, let's do that here. That'll get the y prime by itself. right, and if we do that, we are going to get a final answer that looks like y prime equals 2 minus y e to the xy over x e to the xy plus 2y. Okay, and there's our formula for the derivative.